In the annals of modern warfare, few weapons command the same awe and fear as the Intercontinental Ballistic Missile, or ICBM. These technological marvels, capable of hurtling nuclear payloads across vast distances, have become synonymous with the awesome destructive power of the modern age. ICBMs are more than just weapons. They are symbols of national power, technological prowess, and the ever-present threat of nuclear annihilation. Their existence has shaped global politics, dictated military strategies, and instilled both fear and a sense of uneasy security in equal measure. Since their inception during the Cold War, ICBMs have played a pivotal role in maintaining a strategic balance of terror, deterring large-scale conflicts through the promise of mutually assured destruction. The very existence of these weapons serves as a stark reminder of the fragility of peace and the catastrophic consequences of their use. Yet despite their terrifying potential, ICBMs remain shrouded in secrecy, their inner workings and strategic implications often misunderstood by the general public. ICBMs occupy a paradoxical space in the global consciousness. They are seen as guarantors of peace, their immense destructive power acting as a deterrent. The logic of deterrence creates a stalemate, where any nuclear attack would be met with swift retaliation. This renders such an act illogical. Yet, their existence fills many with dread. The possibility of accidental launch or escalation haunts the world. Critics argue resources could address poverty, climate change, and disease. The debate is complex and multifaceted. No easy answers, no simple solutions. These weapons are not going away anytime soon. Nations perceive their security as intertwined with nuclear weapons. Understanding this issue is crucial for all citizens. Informed debate and nuanced understanding are key to navigating the challenges posed by ICBMs. An intercontinental ballistic missile, or ICBM, is not just a missile, it's a marvel of engineering, a terrifying testament to humanity's capacity for both innovation and destruction. Imagine a weapon capable of traveling thousands of kilometers in less than an hour, carrying within its hull the power to obliterate entire cities. That's the reality of an ICBM. These missiles, towering over their shorter-range counterparts, are defined by their extraordinary range, typically exceeding 5,500 kilometers. This global reach is what sets them apart, giving them the ability to strike targets on different continents, making them instruments of true strategic power. But the defining characteristic of an ICBM is not just its reach, but its payload. These behemoths are designed to deliver warheads, often nuclear, with pinpoint accuracy. The destructive power of a single ICBM warhead can dwarf that of entire arsenals of conventional weapons, making them the ultimate deterrent, a weapon whose use carries unimaginable consequences. The sheer size of an ICBM is imposing, but its true complexity lies within. These technological marvels are not simply giant rockets, they are sophisticated systems, meticulously engineered for maximum range, speed, and accuracy. Understanding how an ICBM works is crucial to grasping its terrifying potential. An ICBM is typically divided into multiple stages, each with its own engine and fuel supply. The first stage, the booster, provides the initial thrust, propelling the missile skyward with incredible force. As the fuel in each stage is expended, the stage is jettisoned, reducing weight and increasing efficiency. The midcourse phase sees the missile traveling through the vacuum of space, guided by sophisticated inertial navigation systems, and, in some cases, satellite guidance. This is where the missile's trajectory is fine-tuned, ensuring it stays on course towards its target thousands of kilometers away. The final stage, reentry, is perhaps the most critical. The warhead, often protected by a heat shield, must survive the intense heat and pressure of re-entering the Earth's atmosphere. It then continues towards its target at hypersonic speeds, making interception extremely difficult. The development of ICBMs revolutionized warfare, ushering in the era of nuclear deterrence. It fundamentally altered the balance of global power. The threat of annihilation now hung over entire nations. ICBMs are strategic weapons designed to deter adversaries. Their possession grants a nation a seat at the table of global powers. It's a dangerous game of chess, where any move could be their last. Advances in technology constantly change the strategic calculus. The world watches, hoping the deterrent effect holds. The journey of an ICBM from launch pad to target is a complex ballet of physics, engineering, and destructive power. It all begins with a fiery birth, a controlled explosion that propels the missile skyward. This is the boost phase, a spectacle of raw power. Deep within lies its heart, a powerful rocket engine. The ignition unleashes immense thrust, overcoming gravity. As it ascends, it sheds spent stages, maximizing range. Each stage is a self-contained rocket, detaching once fuel is spent. The boost phase is critical and vulnerable, with rapid burn boosters reducing this window. Having pierced the veil of the atmosphere, the ICBM enters the midcourse phase. Here, in the cold vacuum of space, the missile embarks on a celestial ballet. With the friction of the atmosphere gone, the ICBM can travel at incredible speeds. But speed alone is not enough. Accuracy is paramount, requiring advanced guidance systems. Most modern ICBMs rely on inertial navigation systems. The midcourse phase reveals its deadliest secret: multiple independently targetable reentry vehicles, or MIRVs. Section 3. The final descent. A devastating return. After its silent journey through space, the ICBM begins its final descent, re-entering the Earth's atmosphere with a fiery vengeance. This is the re-entry phase, a perilous plunge that tests the limits of physics and engineering. As the ICBM screams back into the atmosphere, it encounters intense friction, generating temperatures hot enough to melt steel. To survive this inferno, the warhead is protected by a heat shield, typically made of ablative materials that vaporize upon re-entry, carrying away the heat. During re-entry, the ICBM's trajectory is carefully controlled to ensure it hits its target with pinpoint accuracy. This can involve maneuvers to adjust the warhead's angle of attack, maximizing its range, or minimizing its radar signature. The final moments of the ICBM's journey are a blur of speed and destructive power. Traveling at hypersonic speeds, the warhead slams into its target, unleashing its devastating payload. The impact triggers a chain reaction, a cataclysmic release of energy that vaporizes everything in its immediate vicinity. The ground heaves, buildings crumble, and a blinding flash of light engulfs the sky, marking the terrifying culmination of the ICBM's journey. From V2 to Sputnik. The history of ICBMs is linked to rocket science and 20th century geopolitics. The seeds of this revolution were sown in World War II. Nazi Germany pioneered the V2 rocket, the first long-range ballistic missile. This terror rained down on London, showing the potential of long-range missiles. The V2's impact on rocketry was profound. The US and Soviet Union acquired V2 technology and scientists. This leapfrog led to the ICBM race defining the Cold War. Sputnik's launch in 1957 marked a turning point in the ICBM race. The Cold War arms race, a deadly game of chess. The Soviet Union's early lead in the ICBM race fueled a frantic arms race. Both sides poured vast resources into developing powerful missiles. In 1959, the Soviet Union deployed the R-7 Semyorka, the first operational ICBM. This behemoth marked a new era in warfare. Section 3. Beyond the Iron Curtain, the proliferation of power. As the Cold War raged on, the ICBM club expanded beyond the United States and the Soviet Union. Other nations, eager to assert their place on the world stage and deter potential adversaries, sought to acquire these powerful weapons. France, driven by its desire for strategic independence, developed its own nuclear arsenal and ICBM capability in the 1960s. China followed suit in the 1970s, driven by its rivalry with both the Soviet Union and the United States. The proliferation of ICBMs raised concerns about the potential for accidental launch, miscalculation, or the escalation of regional conflicts into nuclear exchanges. International treaties, such as the Nuclear Non-Proliferation Treaty, aim to limit the spread of these weapons, but the allure of possessing such a powerful deterrent proved difficult to resist for some nations. Despite the end of the Cold War, the threat posed by ICBMs did not diminish. Russia inherited the bulk of the Soviet Union's nuclear arsenal, including its ICBMs. New players, such as India and Pakistan, emerged, further complicating the global security landscape. Section 1. The Unholy Trinity. Range, Speed, Payload. The strategic power of ICBMs stems from a potent combination of factors. It's their range, speed, and payload that make them potent weapons. ICBMs bridge continents, holding targets thousands of kilometers away. Traveling at hypersonic speeds, they cover immense distances in minutes. Designed to deliver devastating warheads, often nuclear, with efficiency. Section 2. The element of surprise, stealth and deception. Beyond their raw power, ICBMs possess another, more insidious advantage: the element of surprise. These weapons can be launched without warning, leaving adversaries scrambling to react and raising the specter of a decapitating first strike. The launch of an ICBM, while detectable, is not easily attributable in the crucial early moments. This ambiguity buys precious time for the attacker and sows confusion among the enemy, potentially delaying or even paralyzing their response. Adding to the element of surprise is the deployment of decoys and countermeasures. Modern ICBMs often release a cloud of decoys along with their warheads, overwhelming enemy radar systems and making it extremely difficult to distinguish real warheads from harmless decoys. This combination of stealth, speed, and ambiguity makes ICBMs incredibly difficult to defend against. The defender is always on the back foot, forced to react to an attack that is already in motion, often with limited information about the scale and intended targets. Section 3. Beyond destruction, the psychological impact. The true power of ICBMs extends far beyond their physical destructive capabilities. These weapons wield a profound psychological influence, shaping the behavior of nations and casting a long shadow over international relations. The possession of ICBMs, particularly those armed with nuclear warheads, fundamentally alters a nation's status on the world stage. It elevates them to the ranks of the great powers, commanding respect, if not always admiration. The threat of nuclear retaliation serves as a powerful deterrent, discouraging adversaries from engaging in large-scale conflicts that could escalate into nuclear exchanges. However, this deterrent effect comes at a cost. The constant threat of nuclear annihilation creates a climate of fear and mistrust, hindering cooperation and fueling suspicion between nations. The very existence of ICBMs serves as a constant reminder of the fragility of peace and the catastrophic consequences of miscalculation or escalation. Moreover, the immense resources dedicated to maintaining and modernizing ICBM arsenals divert funds from other pressing societal needs, such as healthcare, education, and infrastructure. This opportunity cost is a constant point of contention, with critics arguing that these resources could be better spent addressing more immediate global challenges. Potent guarantor of American security. While the United States, Russia, and China dominate the global ICBM landscape, they are not the only players. Smaller arsenals are maintained by other nations, each driven by its own security needs. France, seeking strategic autonomy, has its own submarine-launched ballistic missiles. India, in rivalry with Pakistan, develops its ICBM capabilities. Pakistan, responding to India, has its own ICBM program. The proliferation of ICBMs underscores the complex realities of international security. These weapons remind us of the fragility of peace and the importance of diplomacy. The development and deployment of ICBMs have ignited one of the most contentious debates of our time. It's a debate that transcends national borders and ideological divides. At the heart of this debate lies a chilling paradox. The weapons designed to prevent war may also be the very instruments of our destruction. Proponents argue that ICBMs are indispensable guarantors of peace. They contend that the sheer destructive power creates a stalemate, discouraging nuclear war. Critics argue that mutually assured destruction is a dangerous gamble. The risk of miscalculation or escalation is too great to justify these weapons. Beyond the strategic arguments for and against ICBMs lie deeper moral and ethical considerations. The existence of weapons capable of annihilating entire cities challenges our most fundamental values. Can such weapons ever be morally justified, even as a deterrent? Is it ethical to threaten such unimaginable destruction in the name of peace? Critics argue that ICBMs represent a profound moral failure, a betrayal of our shared humanity. They point to the immense resources devoted to maintaining these arsenals, resources that could be used to address pressing global challenges such as poverty, hunger, and disease. Investing in weapons of mass destruction diverts attention and resources away from more constructive pursuits, perpetuating a cycle of fear and mistrust that undermines human progress. The reliance on nuclear deterrence raises troubling questions about the just war theory. Can a war that targets civilians ever be considered just? Can the threat of such a war ever be morally justifiable? These are questions that continue to vex ethicists, theologians, and policymakers alike. As we navigate an increasingly uncertain future, the debate over ICBMs is likely to intensify. Advances in technology will continue to challenge existing strategic paradigms. The proliferation of nuclear weapons technology raises the specter of regional conflicts escalating into nuclear exchanges. In this complex and perilous landscape, finding a path towards a future free from the threat of nuclear annihilation will require dialogue, cooperation, and a shared commitment to peace. Intercontinental ballistic missiles, these technological marvels born from the crucible of the Cold War, continue to cast a long shadow over the world stage. They are the ultimate paradox, instruments of unimaginable destruction designed to prevent their own use. Their existence has shaped the geopolitical landscape for decades, fostering a climate of both fear and uneasy stability. We have journeyed through the history of ICBMs, traced their evolution from the V-2 rockets of World War II to the sophisticated, multi-warhead missiles of today. We have delved into their inner workings, marveling at the engineering brilliance that allows these technological marvels to hurtle through space with pinpoint accuracy. We have examined their strategic significance, exploring the chilling logic of deterrence that underpins their deployment. Yet, for all our understanding of their mechanics and strategic implications, the true power of ICBMs lies not in their physical attributes, but in their psychological impact. They are symbols of national power, technological achievement, and the ever-present threat of annihilation. Their existence weighs heavily on the global consciousness, a constant reminder of the fragility of peace and the catastrophic consequences of miscalculation. The debate over ICBMs remains unresolved. Arguments for and against their existence are as contentious as ever. Advances in technology add new layers of complexity. Proliferation of nuclear technology complicates global security. Regional conflicts risk escalating into nuclear exchanges. Ensuring peace requires more than technology. It demands dialogue, diplomacy, and disarmament. Recognizing our common humanity is crucial. The future of ICBMs is not predetermined. We must build a safer, more peaceful world.